Hi everyone, welcome to my YouTube channel. Today's topic is interpolation and extrapolation in reduced level calculation. Now, this is basically term used in calculation of earthwork quantities. When you have reduced level, we need to do some interpolation and extrapolation of levels. So, we'll go into the details. Once again, I thank all my subscribers for your continued support. Please watch till the end. If you like, please share and comment. And if you're not subscribed, please subscribe and press the bell icon. So, as I said, the topic is interpolation and extrapolation in reduced level calculation. So, the content of this is we have a road cross section details. So, for example, we have taken a cross section, road cross section details and calculation example how the interpolation is done in the reduced level to calculate the area of the cross section. So, a reverse calculation detail for the same interpolation is done. So it is extrapolation now. Extrapolation is similar to interpolating, and it is when you have levels at 10 meters and 15 meters, but we don't have level at 17 meters. We can extrapolate from 10 to 15 meters level and calculate for the level at 17 meters. Null point, null point is a 0 point. So we'll discuss these contents. So what we see is a road cross section details. So this is the tabulation of the cross section where there is a distance, ground level, formation level is given. Cross section at chain is 220 meters. So this is the central line of the cross section. So this is right hand side and this is left hand side. So the zero chainage is the central line here, and right hand side levels are here, left hand side levels are here. At every 5 meters intervals, the levels are taken. So we have levels written at 0, 6 meters is the ground level, 5.8, 5.55, 5.4, 5.25 is left hand side, and similarly you have levels given at right hand side. So the formation level is, this is the top level. So top level of the formation is taken as 8.5 meters, and 6 meters on the either side of the center point is the top width. So total width is 12 meters. So now we have, this is the ground level which is plotted in red, and this is the top width 12 meters, and you have a slope 2:1 slopes on the sides, and this is the datum. This is how it is cross section area. Now we have 6 meters is the width. So we have an initial ground level at 5 meters and we have a ground level at 10 meters, but we don't have the ground level at 5 meters. So between these two levels, we calculated and fixed the levels at 6 meters. So this is on left hand side. Similarly for the right hand side also, we don't have the ground level taken at the time of initial level. So from 5 meters to 10 meters, it is calculated and fixed here. So this is the example of interpolation. So calculation details. Now we have considered right hand side of the cross section. So we have at 5 meters ground level is 6.15. At 10 meters the ground level is 6.35. So at 6 meters we don't have the level. So it is uh, calculated in this fashion. So the calculation is difference between these two levels. So 6.35 minus 6.15, and the distance between these two levels is 5 meters. So now we want from 5 meters, we want for the 6 meters, the distance is 1 meter into 1. So the levels from here is rising, means from 6.15 to 6.35. So the level at 6 meter is more than 6.15 and less than 6.35. So it is rising here. So this is the at 5 up for 5 meters difference, total difference divided by 5 meters. We want at 6 meters, which is 1 meter distance. So it is 0.04 meters. So initial level at 5 meters is 6.15 plus 0.04, it is 6.95 meters. So So this is how the interpolation calculation is done. And similarly on the left hand side, again we have a level at 5 meters, we have a level at 10 meters. Here the difference is the level is falling. So from 5.8 it is lower, it is going down, the level is going down, which is falling at 5.55 meters. So the 6 at the level you need to calculate is at 6 meters. So difference between these two levels divided by 5 meters, and we require at 6 meter, which is 1 meter distance at, so we get 0.05 meters, so 5.8, and this is falling gradient. So again we need to minus it 5.75. So this is the, we need to see whether it is falling or rising. So if it is falling, it has to be subtracted. If it is rising, it has to be added. So what we have seen in this calculation is we have calculated from 5 meters to 10 meters at the 6 meters, so 1 meter distance. Now we can do the reverse calculation. We can do the same calculation from 10 meters to 5 meters. We can calculate what is the level at 6 meters. So that is a reverse calculation. Instead of coming from 5 to 10, we are going from 10 to 5. So same distance. So what we have taken is reference from 10 meters. So divided by 5. So between these two is 4 meters distance. So we are calculating 10 to 6. It is 4 meters distance. So the value is 0.16, and since it is falling, so it is 6.35, and it is lower than 6.35. So we have subtracted from 10 meter level minus 0.16, 6.15. So if we calculate from 5 to 10 also, it is 6.15. If we calculate from 10 to 5 also, it is 6.19. And same method of calculation here on the left hand side. So earlier we have calculated from 5 to 6. Now in this we are calculating from 10 to 4. So we have taken the same 4 meter distance. It is rising. So 5.55 to 5.8. So we have added plus sign. So 5.55 plus 0.2 is 5.75. So this is how the interpolation is done. And what we have seen so far is the calculation example of interpolation, and extrapolation is also very similar. Only difference is when you calculate extrapolation details, the scenario will be you have a level at 10 meters, you have a level at 15 meters, and you would require to calculate level at 17 meters. So from 10, 15 you have the given levels, and you will extrapolate and find out at 17 meters. The calculation is very similar, and you can calculate by extrapolating with these two levels. So this application of this interpolation and areas is, once you update the cross sectional area, then you have 100 cross section, you will get 100 cross sectional areas, and from these cross sectional areas you get the volume calculation. So the quantity calculation is done with the cross sectional area details. So in the subsequent video, we will also work out how the quantity is calculated from the cross sectional area. So once again, big thanks for watching. So please, if you're not subscribed, please subscribe and press the bell icon. If you like, please comment and share. Thanks for watching. So once again, big thanks for watching. Thank you.